Hello, my name is Barry Olney from In-Circuit Design. This is a quick demonstration of the bi-directional interface between the iCD Stackup planar and Mentor's HyperLynx, LineSim and BoardSim. So first of all, we'll open up HyperLynx LineSim, a freeform schematic, and this is just a typical DDR2 schematic, and we'll open up the Stackup editor. And as you can see, the Stackup is pretty good in HyperLynx. We have 50 ohms impedance on the top micro strip layer and 52 ohms impedance on both the strip line layers and 50 on the bottom again. So we'll just OK that, and we'll go into the Stackup planar, and what we'll do is import the HyperLynx file. Now this imports both LineSim and BoardSim files. So the file we're looking at was this freeform schematic, so we'll just open up this. And here you can see we've got the same 6-layer Stackup and roughly the same impedances, slightly different because the Stackup planar actually takes into account the fact that the copper sinks into the prepreg. So what we need to do is, so we've got the Stackup now into the Stackup planar, is add some dielectric materials. So first of all, we'll look at the prepreg here, and it's a 2.5mm prepreg. So we'll go to prepreg and we'll select, say, a FR408 material, which is an isolon material, and maybe a 2 GHz frequency for that. So we're looking here for something in the order of 2.5mm. So here you can see we've got a 2.2. So I'll just select that, and as we place it into the Stackup, you can see the material that's been used is actually placed in there, and the impedance is changed to correct for that. So we have roughly 50 and 100 ohms, which is good for a DDR2 design. Next we'll select the core, which is 3.5, and we'll edit that material. So again, we'll choose a FR408 from iSlide and a 2 GHz frequency. And now we're looking at something around 3.5. Let's choose something a bit smaller, because what's happening here, I'm using a dielectric constant, which is quite a bit lower than the 4.3 that's standard in HyperLynx, so it will be slightly lower. So if I select a 2.7, it turns out about right, 51 ohms and 93. In the center here, we've got a 44mm prepreg. Now 44mm prepreg is impossible to get, so what you generally do here is put core in the middle and a thin prepreg either side of it. So let's just copy this prepreg from up here, the 2.2mm prepreg, since we already know that's available, and we'll paste that there, and we'll also paste it below the center dielectric that we want to change. Now we need something like a 40mm core to go in the center here. So what I'll do now is edit the dielectric, and we'll look for something like a 40 core, and we'll select a FR408 again, and also the 2 GHz frequency, and we want something that's not 40 but maybe a bit over 40. So let's select a 42mm core to go in the center there. So I double click on that, and that inserts it into the center. So now we need to I'll just copy some of these because we already have them. Copy this and we'll paste it instead of this one here, this core. Remove that one, and I'll take the prepreg from the top here since it's symmetrical, copy, and I'll paste it down the bottom here and get rid of the old one. So here we have a symmetrical Stackup with all the dielectric materials that our fabricator shop stocks. So we know when we produce our board and we output our Gerber files, our fabricator has these materials in stock and can produce the board to the impedances that we have here. So we're going to end up with roughly 52, 53 ohms single-ended impedance and around 100 ohms differential impedance. So I'll just rename this to new HyperLynx HL, and what I'll do is I'll export this to HyperLynx, and already got that before, so I'll just copy over it, and yes, we've created these files. So now I can go back to HyperLynx, to my freeform schematic, and I can go to Setup and the Stackup, and then I can go to Import. And what we'll do is import this new HyperLynx Stackup that I've just created. So once we've imported that, we can go now to the Stackup editor, and you'll see that my new dielectric materials have been put in place. So we have a 2.2 that I put on the microstrip, and I have 2.7 that was in between the first plane VCC and the second signal layer, and I have this core in the middle of 42 with 2.2 either side. So it's extracted that from HyperLynx, and we have a bill of materials. Well, we have a material Excel spreadsheet basically that we can send to our PCB Fabricator then. So I'll just export that to Excel. Maybe a little large to put on the screen here. I'll just open up Excel. There we go. And you can see that we have a complete document here which has all our dielectric materials included, so we can move this over a bit and see all our materials, and it also has differential pairs defined as well. So I'll just close that down for now. And now we'll look at BoardSim. So if we go back to HyperLynx and we select the BoardSim file, I'll just select a HyperLynx file that I was using previously, and we'll just zoom in a little here. Oh, too much maybe. Now this BoardSim file will have a different Stackup again. If I again open the HyperLynx Stackup editor, you'll see that this is a 10-layer board. It's just got default 10mm prepregs between it all, so the impedances are wrong at this stage. I haven't sorted that out yet. So we'll just save that, and what we can do now is from HyperLynx we go to Setup, Stackup Planner, Export, and we export the demo DDR2 demo Stackup. Now I go back to the Stackup Planner and I go to Import, EDA Translators, HyperLynx, and I look for a Stackup file this time. And here's my demo to Stackup that I just created. So again, we can go through and we can edit the Stackup. We may want to change these to like 2.5, 5, 5, and another 5 here. And that's pretty well right, 5100 ohms, whatever, to make that 100 ohms. We can put a 12 clearance in there, differential. And what I'll do is I'll just delete the bottom half of the Stackup to save time, and then I'll mirror the Stackup to create the bottom half of the Stackup. And you can see we've got 50 ohms all the way and 100 ohms roughly for the differential. The thickness of the board itself is 48, so we need to add about 14 to that, so I'll make this say 20 in the center. Should give us our board thickness roughly right. And of course we probably need some solder mask on top and also on the bottom, so I'll just insert those, and I'll rename this to new BoardSim. And then what I'll do is export again to HyperLynx, and this is a new BoardSim FSS, and we've exported that. And going back into HyperLynx, we can go to Setup, Stackup Planner, Import, and oops, in this case we're looking at it for an SDK file. and this is the new BoardSim HyperLynx.stk file that I just created. So I pull that in, and you can see that the Stackup has indeed been changed. You put the solder mask on top, 2.5555, and the 20 in the middle. Okay, so that's a quick rundown on the bi-directional interface between Mental's HyperLynx, LineSim and BoardSim to the iCD Stackup plan.